All right, guys, we're going to do the second set of our notes. And what that means is we are going to focus on this top right corner of our notes. So this section of our notes is going to help us determine what different charges are for cations and anions based on where they are on the periodic table. So you're going to start by drawing a line right here. Everything, if we're making ions, so if we have a ionic bond, everything to... All right, guys, so with these notes, we're going to look at our periodic table, and our periodic table is going to help us determine the charges of different elements. So everything to the left of the orange line I drew makes a positive cation in an ionic bond, just like we talked about in notes today. Everything to the right makes a negative anion when an ionic bond has occurred. So, knowing this information, let's apply it to our periodic table. Everything in this column is going to have an electron configuration ending in S1, which means I have one valence electron. So if I go to draw my Lewis structure, I'll have one electron on top. Now, since it's easier to get rid of one as opposed to build 7 more to get to the octet rule, it's going to get rid of its negative electron, so it's going to get rid of 1, and since it's getting rid of a negative, it becomes more positive, and so it ends up with a charge of +1. So everything in this column that I colored blue has a charge of +1. Now, my second column, they all follow a pattern as well. Their electron configuration ends with an S2, which means that its valence electrons will move around our Lewis structure like that. Once again, it's easier to get rid of these 2 electrons than gain 6 more, so it's going to get rid of 2. And since it's becoming more positive, it's getting rid of negatives, it has a charge of +2. And so everything in this purple column has a charge of +2. Now, we skip over our D block because for this unit we aren't paying attention to our D block. And we're going to skip over to our final column. Now our final column follows this pattern as well. So over here, it has a valence electron configuration of S2P1, which means it has a Lewis structure with 1, 2, 3 valence electrons. Since it's easier to get rid of 3 than to gain 5, it's going to get rid of 3 electrons, and it's becoming more positive. So everything in my green column here has a charge of +3. Now, if you can't notice the pattern yet, the pattern is mimicked on the other side. So, let's talk about this column. This column, everything in this lovely column here has S2P3, which means I have 5 valence electrons to go around my Lewis structure, which means I'm going to have easier to get or fill these empty spaces right here. It's easier to fill these 3 empty spaces with electrons or steal them, so I become more negative. And when I become more negative, what happens is I end up with a charge of -3, because that 3 is the 3 spaces that we need to fill. So everything within this light green row is going to have a charge of -3. Now, what about our row here? And for this one, I'm going to go up just for the terms of space. This one has an electron configuration of S2P4, which means I have 6 6 valence electrons around my Lewis structure. And so it's going to be easier to fill these empty 2 spaces or become more negative. So we're going to end up with a negative 2. So everything in this red column has a charge of negative 2. Now, finally, we're going to move on to the last column that follows a pattern. And so if I go through and everything in this column here has an electron configuration of S2P5, which means my valence electrons I'm going to have 7. And I have only one space here that needs an electron to make that octet rule. So it's going to gain a negative electron and give it a charge of negative 1. So everything in this blue column has a charge of negative 1. So guys, all you need to do on this worksheet is draw me your Lewis structure, so it'll follow one of these patterns, and then tell me the charge. Last thing we're going to go over is this lovely column over here, our noble gases. And those noble gases have no charge because every single one of them has a full octet. So my element has 8 valence electrons and so has no interest in giving or getting rid of electrons because it's already completely stable. Before I leave you, let's go over one problem from our worksheet. So what it's going to look like is, let's go with magnesium, Mg, draw my Lewis structure. Magnesium's electron configuration is 1s2, 2s2, 2p6, 3s2. So I find out how many valence electrons I have by finding whatever has the highest. So I have 2 valence electrons. So I draw my 1, 2 valence electrons. So figure out if this is going to lose or gain electrons. If I look at my periodic table, it is to the left of the line we drew, so it's going to lose electrons. And because it's got 2, it's going to have a charge of positive 2, because it's going to lose its 2 electrons. Any questions, guys? Please reach out to me via Remind.